My name is Chen, a graduate student at the University of Arkansas, and today I'm going to present on what I did for the National Geo Prediction 2022 in Charlotte, North Carolina. So starting with the project description of this competition, we are given a sand and gravel embankment that were constructed in three stages, and it were on a saturated clay soil. The soil profiles at the center line of the embankment is displayed in the figure number 2. We have abundant of highly organic clay and very soft clay at 50 feet below the ground surface, and the water table is at 2 feet, so most of the clay is saturated. The soil property including the in-situ water content, total unit weight, and in-situ shear strength are given in figure number 3 and figure number 4. Based on the undrained shear strength, we're going to divide it 50 feet of clay layer into 6 sub-layers for a more accurate consolidation calculation. The monitoring was set up immediately after the construction began. Our task is to predict the vertical settlement at the point U1, V1 after 500 days and the lateral deformation at the point L1, L2, R1, R2 after 44 and 240 days. The accuracy of the predictions will be determined based upon the actual field measurement. Our prediction for how the soil behaves under the embankment load is presented in the figure number 1. We predicted that the resulting change in the stress immediately caused distortion in settlement at the center of the embankment and some corresponding lateral movement of the soil to the side. Some uplifting or heaving at the site gonna happen as well. For the methodology, I divided into 2 sections. The first one is a method that we use to calculate the vertical settlement at the center line and at the toes of the embankment. The second section is a method that I use to calculate the horizontal deformation at the side of the embankment. The first part is a vertical settlement calculation. Here's one of the equations that I use to calculate the vertical settlement. The total vertical settlement is a sum of elastic, primary, and secondary settlement. Elastic or short-term settlement is a settlement that occurs immediately after the load is applied. However, the effect of elastic settlement on clays is negligible to small, so we did not consider the elastic settlement for our calculation. The secondary settlement is the settlement caused by the decomposition of the organic clay and the creep effect of the clay layer at the site. Even that the effect of decomposition and creep effect is really significant for organic clay, I ignore the secondary settlement calculation because our investigating time is only 500 days maximum, while the secondary settlement should be considered for the time span of 5 to 10 years. Therefore, the calculated settlement were based only on the primary consolidation. According to the spring analogy, the primary consolidation occurs when the induced stress causes a build-up in excess water pressure in the piston, and then now when the pressure inside the piston is greater than the outside pressure, the water is squeezed out from the soil voids and causes the soil grains to rearrange and come into a denser configuration. The primary settlement and time rate of consolidation is calculated following the one-dimensional consolidation theory from Tezaki in 1925. The over-consolidation ratios were not given, so the soil is assumed to be normally consolidated condition. Based on the equation, to calculate the vertical settlement, we need to know the induced stress, the compression index, the initial void ratio, and the permeability. And these are unknown for us, so now I'm going to show you how did we find out these parameters. The induced stress due to the embankment loading at the center line and the toe were calculated based on the Osterberg method as presented in figure 6. We know the unit weight, the height, the geometry of the embankment, so we can calculate the induced stress at the center line easily based on the Osterberg equation right here. Because the solution is for half an embankment, a factor of 2 was used to calculate the total induced stress. To calculate the induced stress at the top of the embankment, we drew an imaginary brown triangle. The induced stress at the top of the embankment will be equal to the induced stress of the embankment plus the triangle, subtract to the induced stress caused by the triangle alone. So for the triangle, induced stress caused by the triangle, the B1 value will put to be 0. What is presented in figure number 7 is our induced stress result. The red circle is the stress increase at the center line of the embankment for stage 2. The purple circle is for stage 3, and as you can see, the induced stress at the center line is not a constant number. It should decrease with each increasing depth. The induced stress at the edge is very small on top. I got the peak at 17 feet and reduced with depth after getting the peak. So for the vertical settlement calculation, other unknown parameters include the compression index, initial void ratio, and permeability. The compression index for the organic soil and peat were correlated with the in-situ water content found on a correlation presented in EM1110. The initial void ratio were calculated based on the correlation between the void ratio and the compression index for organic clays by utilizing Nishida correlation. The permeability was selected based on a strict standard for organic clays of high plasticity. The minimum and maximum range for the organic clays is between 1.64 10 to negative 9 feet per second to 3.28 to 10 negative 7 feet per second. Based on the correlation, we come up with the property of the soil as presented in table 1. Because the actual settlement at the center line of the embankment after 10, 50 and 100 days are given to us, we did the back calculation process. We fixed CC and E0 value while adjusting the permeability values, and iteration happened until the monitoring and the calculated settlement were matched. Here is a computed settlement result that we got after 50 and 100 days of construction. As you can see, the monitoring and the calculated settlement match really well with each other. According to our vertical settlement calculation, we will have a total settlement of 55.4 inch at the center of the embankment. The degree of consolidation after 50 and 100 days of construction is approximately 10 to 14%. Now we are confident with our soil parameters, so we're going to use that information to calculate the vertical settlement at the center line and at the top of the embankment after 500 days. The top one is at the center line and the bottom one is at the top of the embankment. The degree of consolidation is approximately 31% and a settlement of 16.8 inch is expected. That is a lot of settlement for not a very high embankment. However, consider that we have 50 feet of organic and soft clay. The result did make sense. Also, the settlement at the edge also 1/3 the settlement at the center, so the result also reasonable. The lateral movement at point L1, L2, R1, R2 were predicted following the influence diagram for horizontal normal straight along the selected vertical straight section for 30-degree slope from Perloff et al. 1967. The Perloff method was selected for the calculation of lateral movement because the Perloff method is for straight distribution within and under the long elastic embankment. Boussinet and Newmark solutions are typically only for foundation. The total vertical settlement at 44 and 240 days were multiplied with the ratio found in the influence diagram to predict the lateral movement. The influence factor of 0.16, 0.11, 0.15, 0.09 was selected for our point L1, L2, R1, R2 respectively. Those numbers were then multiplied with 2 to account for the effect of the whole embankment. The lateral movement were found to decrease with depth as well. Here our vertical settlement calculation at the center line after 44 and 240 days. we multiply the vertical settlement with the influence factor from the previous slide to get the lateral deformation. So 44 days and 240 days. Conclusion. So presented in our table 2 is our final prediction for the horizontal and vertical movement due to the construction of the embankment. Assumption and limitation include: first, the soil consolidation property and current soil state were unknown, so the consolidation calculation were determined based on the literature review correlation by calculation of the provided settlement at the center line. Second, with a thick layer of clay, we assume the drainage condition to be single drainage. The soil was assumed to be normally consolidated. Third, the calculation were based on empirical equation and many engineering judgment, so the calculation should be used for low to medium risk project only. Finally, numerical modeling like Placid software could be included to compare and verify the experimental calculation. So that's here is a list of reference that we use for our prediction. And that's the end of our presentation. Thank you for your attention, and have any question, please let us know. I'm ready to answer.